In this video, I would like to show how to create and use mapped types. A mapped type allows us to create a new type by iterating over a list of properties. For example, in here we have a list of properties in a union type, and we can use this list to create a new type where each of these properties will correspond to some value. Now I would like to go through a number of examples. I opened VS Code, and let's start with a very simple example. Let's say we have a list of properties, prop A and prop B. Now we can use this list to create a new type. And inside of this type, we iterate over these properties. Inside of square brackets, we type the following. For every property P, this type variable will hold the property name. So for every property P in a list of properties, we create a new property in this type. And now we can assign some value to this property. For example, we can describe each of these properties as a boolean. So as a result, we will get a new type where each of these properties is a boolean. Also, we can use this property name on the right side of this expression, like this. So we will get a new type where each property will have as a value its name. Later, we will use this property name on the right side of the expression to get the type of the property value from some existing type. We can use a mapped type to create a new type from an existing type. And I will use generics to accomplish this. So let's turn our mapped type into a generic type. So let's take the properties list as a generic type parameter. Let's call this parameter properties. There is an error, let's check it out. Properties is not assignable to type string, number, or symbol. So TypeScript expects a property to be either a string, number, or a symbol. But the type parameter properties we get in here can be anything, from a boolean to a map. So let's add a generic type constraint to make sure that every property in this union is either a string, a number, or a symbol. Okay, the error is fixed. So now we can create a new type from this generic. We can pass the property list as a generic type parameter, like this, and we will get a new type. Okay, now let's use a mapped type to create a new type from an existing type. So let's modify our generic here, and instead of taking the properties as the generic type parameter, we will take the whole type. Let's call this type T. And what we will do is to copy this type. And for this, we will need to get the list of properties of this type and iterate over this list to create a new type with that properties. And to get the properties of this type as a list, as a union, we can use the keyof keyword. Like this. So for every property P in keyof T. And keyof T gives us a union of all the properties in T. So basically what we will do is we will copy the type T. And on the right side, now we can use the name P, the property name P, to get the type of the value in T. And for this we say T square brackets P. So we get the type of the value of P in T. So basically this type will just copy the type T without modifications. So here let's pass some type like this. So A is A and property B is B. And for the result we get a new type with the same properties and values. Now instead of just copying this type, let's try to modify it somehow. For example, we can make each property read-only like this. And we will get a new type with all properties read-only. Or we can make each property optional like this. We will get a new type with optional properties. Or we can modify the type value somehow. For example, make it nullable. And we will get a nullable type like this. So every property can be null. TypeScript's built-in types like pick and record use mapped types behind the scenes. So in the next examples, I would like to show how to recreate these types using mapped types. So let's start with pick. I will call it pick1 because pick already exists in TypeScript. So pick takes an existing type, picks some properties from this type, and creates a new type with only that properties that it picked. And we tell it which properties to pick. So let's take as a generic type parameters two parameters. The first one is the existing type, and the second one is the list of properties that we would like to pick from type T. Let's call this type parameter properties. And we need to make sure that these properties exist in type T, and for this we will add a generic type constraint saying that properties belong to the list of properties of type T, and to get the list of properties of type T we use the keyof keyword and keyof T. Now let's iterate over the properties that we would like to pick. For this we type for every property in properties. We will create this property with the original type of this property value. So we take this as TP. And now we can use this type to pick a few properties from an existing type like this. So let's take from type A, B, only the property A, for example. And as a result, we get a new type with only the property A from the original type. We can take two or more properties using a union like this. And we will get basically the same object because it has only two properties. Another type that I would like to recreate is record. First, I would like to check the original type definition of the record. For this, I will click over the record's type name, and here it is. It's a generic type which takes two type parameters k and t. The first type parameter describes the record's keys, and the second type parameter t describes the record's values. Then for every key in k, a record allows us to create a property with type t. An interesting notation here is keyof any. Let's check what it resolves into. For this I will hover over the k parameter, and here it is. K extends a union of string, number and symbol. Here. So keyof any resolves to this union type. Okay, now let's have a look at how to use the record type. I will copy the definition to have it for the reference. Let's paste it here and rename it. Okay, so now let's use a record. So some record is a record of strings for the keys and let's say numbers for the values. Now I can add properties to some record on the fly like this. Let's say we have 10 apples. Also, let's say we have 10 oranges. And I can continue adding properties to this record like this. Now you might ask, why do I use a record if I can use an index signature in here? So let's create an index signature. Let's call it record2. And for the keys in this index signature, we will have strings. And for the values, numbers. Exactly like we have in the record type we created. And actually this index signature will be the same as this type we have here. We can even replace it with record2, like this. So why do we need a record if we can use an index signature? The thing is that index signature has a limitation as to what keys we can describe here. For example, we cannot use a union to describe the keys of an index signature like this. So we cannot say string or number. We will get an error for this. saying the following. Index signature parameter type cannot be a union type. Consider using a mapped object type. So we cannot use a union to describe the keys of index signatures. We can use either strings or numbers. While using the record, we can say that this record keys may be strings or numbers, or maybe some union of string literals, like this. Let's say we have record 1, and the keys can be numbers or strings. And the values, let's leave it as a number. And now I can add a number as a key to this record. Let's say 1 is equal to 1. Also, I can describe the keys as a union of string literals like this. Let's say this record will have keys A and B, which are numbers. Now I have to initialize these keys here. A is 1 and B, let's say it's 2. So that's it about the record. Now, what if I wanted to add a specific property to some map type? For example, let's say to record 1, I would like to add a property called SomeProperty of type string. A map type doesn't allow me to do this, but I can still do it using an intersection type like this. And for the result, I will get the following type. Some record should now have some property. So a mapped type is merged with another type which has some property. So because some record is record 1, I will have to add this some property to it like this. Oh, it should be a string. So in this video we learned how to create and use mapped types. Thanks for watching it.